Next, let's look at how to measure distance between clusters. We have two clusters, and there is not one single record against another single record. It is one cluster of records against another cluster of records. So how do you measure the distance? So we have again several ways in which we can do this. One is minimum distance. This is called single linkage. Distance between two clusters is the distance between the pairs of records that is closest. So you find all possible pairs from the two clusters, find the distance, and then find the closest pair, and that distance is then used as the distance between the two clusters. So that is called single linkage. Then you have complete linkage, which is the opposite of single linkage, which is you again do the same thing, find the distance between all pairs of records, and then select the one that is farthest apart and use that as the distance between the two clusters. Another one is the average. So again, you find the pairwise distances and then find the average of all those pairwise distances, and that is your distance between the two clusters. And another one is centroid distance, and that is you find the centroid of one cluster and you find the centroid of the second cluster, and then find the distance between the two centroids, and that is centroid distance. Okay, now let's look at these distances in Excel. Okay, so now we are in sheet 2, the same data set. Okay, but we're going to look at only two variables, okay, to keep the computation simple, and we're also going to do a z-score normalization, right? So we need the sales and the fuel cost, right? Then we find the mean, and the standard deviation, okay, dot yes. Okay, so I'll copy that. So right now you have error, but once we fill out these two columns, you will have the proper results. Okay, so okay, so now let's do the normalization. X minus x bar. Okay, so we need the x bar should be rho absoluted divided by standard deviation, and again it should be absoluted for the rho. Now you see the mean is 0 and standard deviation is 1 for z-scores. Okay, so now we have standardized the two variables. Now we need to find the equilibrium distance between all pairs, right? So we have and we are going to use only the first 5 observations. Okay. Actually, we need to be doing this calculation for all the 22, but to keep the computation simple, let's only look at the first 5. Okay, so the distance is only it's a symmetric matrix, so we will fill out only the bottom half. Okay, so the diagonal will not have any value because it'll be 0. Distance between Arizona and Arizona will be 0, right? All right, so now let's look at distance between Boston and Arizona. So that will be square root of sum of x minus y squared. So now we need the two ranges. So that is Arizona. Okay, so I'm going to absolute reference this so we can copy this down, because Arizona to Boston, Arizona to Central, Arizona to Commonwealth, and so on. Then the second one is Boston, right? So we're using only two variables for simplicity. So when we do this in SAS, we will consider all the variables and all the observations. Okay, so now two right parentheses, and we get the distance between Arizona and Boston. So now we copy that down and we get the rest of the distances. So next we have to do the same thing, square root of sum x m y2. Now this time Boston, okay, Boston should be absolute referenced, and then Central. Okay, one more parenthesis. Okay. Copy that down. And then square root of sum x m y2. Now Central, that one, absolute reference that, and then Commonwealth. Okay, and then two right brackets. So now we can copy that down to get the distance, and then the final one. So this one is SQRT sum xmy2 Commonwealth, and we're not going to have to copy this, so I'm not going to do absolute reference, and one more right parenthesis, and we have the distance.